Today we are going to discuss very important topic, that is progressions. That is progressions. First of all, what is the progression? Before going to discuss progression, first of all, what is the sequence and what is the series and what is the progression? Let us discuss one by one. First of all, what is the sequence? Sequence is an arrangement of numbers. Sequence is an arrangement of numbers in a definite order according to some definite rule is called sequence. A sequence is an arrangement of numbers in a definite order according to some definite rule. A sequence is an arrangement of numbers. It's nothing but arrangement of numbers. A sequence is an arrangement of numbers. In a definite order. Order is nothing but either ascending order or descending order. A sequence is an arrangement of numbers in a definite order. Order is nothing but either ascending order or descending order according to some definite rule. Means it follows some logical rule. Then it is called what? Sequence. A sequence is an arrangement of numbers in a definite order according to some definite rule is called what? Sequence. For example, let us take 1, 3, 5, 7, 9 and so on. Observe here 1, 3, 5, 7, 9 and so on. The sequence is an arrangement of numbers. Already here arrangement of numbers in a definite order. Observe here, this is a ascending order. In a definite order. That means in a definite order means arrange these numbers in a ascending order according to some definite rule. Means observe here every term except first term, if we add +2 its preceding term, we get next term. 1 plus 2 we will get +2, we will get 3 plus 2 we will get 5. 5 plus 2 we will get 7, 7 plus 2 we will get 9 and so on. So sequence is an arrangement of numbers. Nothing but arrangement of numbers. In a definite order. Order is nothing but either ascending order or descending order. Order is nothing but what? Either ascending order or descending order. And according to some definite rule, it means it follows some logical rule. Is called a sequence. It's called a what? Sequence. Next take another example. 0, 1, 2, 3, 5, 8, next 13 and so on. Observe, this is a sequence. This is also a sequence. Arrangement of numbers in a definite order. I will arrange in definite order. That means ascending order. According to some definite rule, it follows some logical rule. Observe here, except first two terms, every term, we add preceding two terms, we will get next term. Observe here, 0 plus 1 is nothing but 1. 1 plus 1 is nothing but 2. 1 plus 2, that is 3. 2 plus 3, that is 5. 3 plus 5, that is 8. 5 plus 8 is nothing but 13, and so on. This is also a sequence. Why? Because this is the arrangement of numbers. Arrangement of numbers in a definite order, and according to some, it follows some logical rule. So this is also a sequence. That means a sequence. A sequence is an arrangement of numbers. This sequence is an arrangement of numbers in a definite order. In a definite order, according to some definite rule, is called sequence. It's called what? Sequence. A sequence. A sequence is a function. A sequence is a function whose domain is subset of a sequence is an arrangement of numbers in a definite order according to some rule or another definition. A sequence is a function. A sequence is a function whose domain is a subset of natural number. A sequence is a function. A sequence is a function whose domain is a subset of natural number. Is called what? Sequence. Let us discuss an example here. F of x is equals to 2x plus 1. F of x is equals to 2x plus 1 for all x is belongs to n. X is belongs to n means whose domain? Whose domain is what? Input. Input means domain. Is the what? Natural number is a subset of natural number. A sequence is a function. A sequence is a function whose domain is the subset of natural number. A sequence is a function whose domain is the subset of natural number. If you observe f of x is equals to x plus 1, if you substitute x value 1, 2 1s are 2, 2 plus 1 how much? 3. If you substitute x is equals to 2, 2 2s are 4, 4 plus 1 how much? 5. If you substitute 3, 2 3s are 6, 6 plus 1 how much? 7. If you substitute 4, 2 4s are 8, 8 plus 1 how much? 9, and so on. So that's why a sequence is a function. A sequence is a function whose domain is the subset of natural number. A sequence is a function whose domain is a subset of natural number. So observe here. A sequence is a function. A sequence is a function. A sequence is a function whose domain is the subset of natural number. Whose domain is the subset of natural number. And whose range is nothing but output. Whose range is a subset of real number. A sequence is a function. A sequence is a function whose domain is natural number, subset of natural number, and whose range is subset of real number. Then it is called real sequence. Then it is called what? Real sequence. A sequence is a function whose domain is the subset of natural number and the range is the subset of real number. Then it is called what? Real sequence. A sequence is a function whose domain is the subset of natural number, whose domain is the subset of natural number, and whose range is the subset of complex number. Whose range is the subset of complex number. Then the sequence is called complex sequence. A sequence is a function whose domain is the subset of natural number and whose range is the subset of complex number. Then it is called complex sequence. Observe here, sequence is an arrangement of numbers in a definite order according to some rule is called what? Sequence. Observe here, sequence is an arrangement of numbers. Arrangement of numbers in a definite order according to some rule is called sequence. In a sequence is nothing but arrangement of numbers. In the sequence is what? Arrangement of number. Each number is called in a sequence. Each number is called a term. Each number is called a what? Term. In a sequence. in a sequence various numbers. In a sequence, various numbers occurs are called what? Terms. In a sequence is nothing but what? Arrangement of numbers. Sequence is nothing but arrangement of numbers. That means in a sequence, various numbers occurs. These numbers are called what? Terms. Generally, terms are denoted by A1, A2, A3, and so on, or T1, T2, T3, and so on. In a sequence, various numbers occurs. These numbers are called what? Terms. So terms are generally denoted by A1, A2, A3, and so on, AN, or T1, T2, T3, and so on, TN. This is called what? Sequence. Sequence completed. Next, series. Series means the sum of the terms, in a sequence is called series. The sum of the terms in a sequence, is called what? Series. That means in a sequence, each term connected by plus or minus sign, then a series is obtained. That means the sum of the terms in a sequence, is called what? Series. The sum of the terms in a sequence is called series. Is nothing but in a sequence, each term connected by plus or minus sign, then a series is obtained. Let us discuss here. If A1, A2, A3, and so on, A1, A2, A3, and so on, AN, T1, T2, T3, and so on, TN, is a sequence. The sum of the terms in a sequence is called a series. That means A1 plus, A2 plus, A3 plus, and so on, plus AN is called series. A1, A2, A3, and so on, AN is a sequence. The sum of the terms in a sequence is called a series. That means A1 plus A2 plus A3 plus and so on plus AN is called a series. Example here: 1 plus, 2 plus, 3 plus, 4 plus, and so on plus 100 is a series. 1 plus 2 plus 3 plus 4 plus and so on plus 100 is a series. 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus and so on is also a series. The sum of the terms in a sequence is called a series. Or in a sequence, each term connected by plus or minus sign, then a series is obtained. Generally, series two types: finite and infinite series. Generally, series is two types: finite series and infinite series. Finite series, infinite series means a series is a finite, then according to number of terms involved in a sequence, then we say that the series is finite or infinite. If a series has a finite number of terms, a series has a finite number of terms, then it is called finite series. A series has a finite number of terms. We know that finite number of terms. That means that if counting purpose, if you count the articles or numbers, compulsory surely it will end. Is called what? Finite numbers. So finite series. Finite series means it has finite number of terms. It has finite number of terms is called a finite series. A series which has infinite number of terms, a series which has infinite number of terms, then it is called infinite series. So let us discuss here one example. 2 plus 4 plus 6 plus 8 plus and so on plus 100. Observe this series. Observe this series 2 plus 4 plus 6 plus 8 plus and so on plus 100. It's and this surely comes with an end. So it has finite number of terms. It has finite number of terms. So this is called finite series. Next one, 1 plus 5 plus 9 plus 30 plus and so on. And so it has no endpoints. So this is called infinite series. Series is what? Series is the sum of the terms in a sequence. The sum of the terms in a sequence is called a series. Now, nothing but in a sequence, every term connected by the sign plus or minus, then a series is obtained. Series is two types, that is finite series and infinite series. Finite series means a series has or a series contains finite number of terms. A series has a finite number of terms, then it is called finite series. A series has a finite number of terms, so this is called a finite series. A series has infinite number of terms. A series has an infinite number of terms, then it is called infinite series. Then it is called what? Infinite series. Progression means the sequence whose terms follow a certain pattern, that it is called progression. The sequence whose terms follow a certain pattern. The sequence whose terms follow a certain pattern, then it is called the sequence whose term follows some certain pattern, some specific pattern, then they are called progression. That means the sequences follow a certain pattern is nothing but if you add except first term, every term, if you add some constant, we get the next term, or if you multiply the every term except first term, we get the next term. Okay, every term, some divide some constant, we get the next term. That means the sequence whose terms follow a certain pattern. The sequences whose terms follow a certain pattern, then it is called what? Progressions. Then it is called what? Progression. So what is the main difference? What is the main difference between the progression and the sequence means? What is the main difference between the progression and the sequence means? The progressions which has a specific formula. The progression which has a specific formula to calculate the nth term. Whereas sequence based on logical rule does not have any formula to calculate the nth term. Does not have any formula to find the nth term. That is the main difference between the progression and the sequence. Observe here, what is the difference? What is the difference between the progression and the sequence means? A progression which has a formula to find the nth term, to calculate the find the nth term, whereas sequence based on logical rule, does not have any formula to find the nth term. For example, if you take the set of prime number is a sequence, but it does not have any formula to find the nth term. That is the main difference between the progression and sequence. Example 1, 4, 7, 10, 13 and so on is a progression. 1, 4, 7, 13, 10, 13 and so on is a progression. That means every term except first term we add plus 3, we get next term. Next, take 2, 4, 8, 16, 32, 64 and so on is also a progression. Every term except first term, if you multiply by 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64 and so on. This is also a progression. Okay, next 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 30 and so on. It is also a progression. Next 1 by 1, 1 comma, 1 by 2 comma, 1 by 3 comma, 1 by 4 comma, 1 by 5 comma and so on. This is also a progression. Progression is what? The sequence whose terms follow a certain pattern. Is called what? Sequence. Is called a sequence. The sequences whose terms follow a certain pattern is called what? Is called progression. What is the main difference between the sequence and progression? Means a progression has a specific formula. To calculate the nth term, whereas sequence based on logical rule, it does not have any formula to find the nth term. Okay. For example, take one example: 0, 1, 1, 2, 3, and so on. Here, every term except first two term we add first. Before preceding two terms we get the next term. Here there is no formula to find the nth term. This is a sequence. This is a sequence. This is not a progression. The set of prime numbers, observe prime numbers 2, 3, 5, 7, 11, 13 and so on. It has one rule. It follows one logical rule, that is prime numbers, but it does not have any formula to find the nth term. So these are all sequences. Observe here, all the progressions are sequences, but all the sequences need not be progressions. Okay, that means which sequence follows certain pattern, which sequence to find the nth term, they are called progressions. That is the sequence whose terms follow a certain pattern is called what? Progression. Progressions are mainly 5 types. First one, arithmetic progression. Simply AB. Progressions are mainly 5 types. That is, first one is arithmetic progression. Second one is geometric progression. Simply it is denoted by GB. Next, third one, arithmetico geometric progression. Arithmetical geometric progression or arithmetic geometric progression, that is AZP. Simply it is denoted by AZP. Progression are mainly 5 types, that is arithmetic progression, geometric progression and arithmetico geometric progression. Fourth one, harmonic progressions. simply it is denoted by HP. And fifth one, miscellaneous progressions is nothing but some progression like this: 1 into 2 plus, 2 into 3 plus, 3 into 4 plus, and so on. These type of progressions are called miscellaneous progressions. Okay, progressions are mainly 5 types. Progressions are mainly 5 types. That is arithmetic progression. First one is what? Arithmetic progression. Second one, geometric progression. Second one, what? Geometric progression. And third one, arithmetico-geometric progression. That is nothing but ACP. Next, fourth one, harmonic progression. Fourth one is harmonic progression. And the fifth one is miscellaneous progression. Miscellaneous progressions are 1 into 2, 2 into 3, 3 into 4, and so on. This type of progressions are called miscellaneous progressions. Let us discuss one by one. First one is arithmetic progression. First one is arithmetic progression. Arithmetic progression means the progression is said to be arithmetic progression. The progression is said to be arithmetic progression if the difference between a particular term and just previous term. If the difference between a particular term and just preceding term is always constant. A progression is said to be arithmetic progression if the difference between a particular term if the difference between a particular term and just preceding term, just previous term or preceding term, the difference between a particular term and just previous terms is always constant. A progression, first one, arithmetic progression. Arithmetic progression means a progression is said to be arithmetic progression. A progression is said to be arithmetic progression if the difference between a particular term, and just previous term or just preceding term is always constant. A sequence is said to be arithmetic progression. A sequence is said to be arithmetic progression if the difference between any two consecutive terms is always constant. If the difference between any two consecutive terms, is always same. Progression means arithmetic progressions are mainly 5 types. That is arithmetic progression, geometric progression, arithmetico-geometric progression, harmonic progression, and miscellaneous progression. First one, arithmetic progression. Arithmetic progression means a progression is said to be arithmetic progression. If the difference between a particular term and just previous term, is always a constant, then the progression is called arithmetic progression. Or a sequence is said to be arithmetic progression, if the difference between any two consecutive terms, is always same. If the difference between any two consecutive terms is always same, then the sequence is called arithmetic progression. That is That is, if A1, A2, A3, A4, and so on, AN are in arithmetic progression. That means A1, A2, A3. That means sequence whose terms are in arithmetic progression. The difference between any two consecutive terms, is always same. The difference between any two consecutive terms, take A2 minus A1, is same as A3 minus A2, is same as A4 minus A3. Is same as, and so on, is equals to AN. The preceding term is nothing but AN minus 1. So AN minus 1. The difference between any two consecutive terms, is always the same. This constant quantity is always a constant quantity. This constant quantity is denoted by the constant quantity. The constant quantity is denoted by letter small d. The difference between any two consecutive terms, is always a constant quantity or same. The difference between any two consecutive terms is always same or constant quantity. This constant quantity is denoted by letter small d and read as common difference. Observe here, the constant quantity, the difference between any two quantities, the difference between any two consecutive terms, is same or constant quantity. This constant quantity is denoted by D, is nothing but common difference. So common difference is equals to D is equals to A2 minus A1 or A3 minus A2 or A4 minus A3 and so on, AN minus 1 is equals to common difference. So what is the formula to find the common difference? Means D is equals to A2 minus A1 or A3 minus A2 or A4 minus A3 or AN minus 1. The difference between any two consecutive terms, is called as a common difference. Common difference is denoted by letter D. Example. Observe this example: 3, 8, 13, 18, and so on. This is a sequence. What is the difference between any two consecutive terms? If it is in arithmetic progression, is not how to check means the difference between any two consecutive terms. Take here A2 minus A1. A2 minus A1 is equals to how much? 8 minus is nothing but 5. A3 minus A2 is nothing but 13 minus 8 is nothing but 5. A4 minus A3 is nothing but 18 minus 13 is nothing but 5. So the difference between any two consecutive terms, is same and a constant quantity. This constant quantity is denoted by the common difference, is denoted by the letter D. And so clearly 3, 8, 13, 18 and so on is in arithmetic progression. Is nothing but in arithmetic progression every term except first term. If you add some constant, we get the next term. Then the sequence are called arithmetic progression. Arithmetic progression means, once again, a progression is said to be arithmetic progression. The difference between a particular term and just previous term. The difference between a particular term and just previous term. The difference between a particular term and just preceding term. The difference between a particular term and just preceding term is always same and a constant. This constant quantity is called common difference. Or a sequence is said to be arithmetic progression. A sequence is said to be arithmetic progression if the difference between any two consecutive terms, is always same and a constant. Then the sequence is called what? Arithmetic progression. Is called what? Arithmetic progression. Arithmetic progression means a sequence is said to be arithmetic progression. The difference between any two consecutive terms. Is always same. What is the general form? Of arithmetic progression? What is the general form? How to write the arithmetic progression with the common difference D? Let us assume that let A is the first term, and D is the common difference. D be the common difference. The general form of an arithmetic progression is observe here, A is the first term and D is the common difference. And how to write the general form of arithmetic progression is, observe here, A is the first term, A. D is the common difference, that means the constant D. Everywhere the difference between any two consecutive terms is always a constant. The constant is called here D. If you add every term constant, we get the sequence, that is called arithmetic progression. Here the common difference, the constant is almost D. If we add D to first term, we will get second term, that is A plus B. This is second term. If we add D to second term, we will get third term, that is A plus B plus D is nothing but A plus 2D. If we add D constant to third term, we will get fourth term, that is nothing but A plus 2D plus D is nothing but 3D. If we add constant D, fourth term, we will get fifth term, is nothing but A plus 3D plus D. And how much? A plus 4D and so on. Is a general form of a arithmetic progression. A is the first term, and D is the common difference. A is the first term and D is the common difference. Then the general form of arithmetic progression is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, and so on. How to find the nth term? How to find the nth term of an arithmetic progression? We know that progression has a specific formula. To calculate their nth term. So how to find their nth term in the arithmetic progression? Right. Next. Nth term of general term of an arithmetic progression. Nth term of general term of an arithmetic progression. How to find the nth term or general term of the progression? General term is nothing but, if you observe here, 2, 4, 2, 5, 8, 11, 14. Observe here, this is a sequence. It is in arithmetic progression. Why? Because the difference between any two consecutive terms, 5 minus 2, 3, 8 minus 5 is 3. 11 minus 8, 3. 14 minus 11, 3. So this sequence clearly it is in arithmetic progression. Clearly it is in arithmetic. This is first term, this is second term, this is third term, this is fourth term, this is fifth term. What is the 100th term? And what is the 1000th term? And what is the 2020th term? If you write like this, add plus 3, add plus 3, add plus 3 means it is very time consuming. So that's why we have a formula to find the nth term or general term of the arithmetic progression. Yes, we know that A is the first term. A is the first term and B is the common difference. B is the common difference. The general form of an AP. The general form of an AP is nothing but A plus B, A plus 2D, A plus 3D and so on. This is the general form of arithmetic progression. General form of arithmetic progression. We want nth term or general term. How to find this? Observe here. A is the first term. A is the first term. So first term is denoted by A1. First term is denoted by A1 or T1. Take anything. A1 or T1. A1 is equal to how much? A. This is what? Second term. So second term A2 is denoted. Second term is denoted by A2. That is our T2 is how much? A plus B. Third term how much? Third term A3 is equals to A plus 2D. Fourth term A4 is equals to A plus 3. We know that 1 is a multiplicative identity. 1 is a multiplicative identity. So A can be written as A into, we want additive identity. So 0 is, we know that 0 is a additive identity. 0 is a additive identity. So A can be written as our convenience A plus 0. A plus 0 is equals to 0 plus A is equals to A only. Okay, now we know that additive identity property A plus 0 equals 0 plus A is equals to A. So A can be written as our convenience A plus 0. A plus 0. 0 into anything is equals to 0. So A plus 0 can be written as A plus 0 can be written as 0 into D. 0 into D is nothing but 0. So A plus 0 is nothing but A only. There is no change in this equation. So 0 can be written as our convenience. 0 can be written as our convenience. The position of A is first term. The position of A is first term. According to the position can be written as A plus 0 can be written as 1 minus 1 into D. 1 minus 1 into D. 1 minus 1 how much? 0. 0 into D is nothing but 0. A plus 0 is equals to A. There is no change. Our convenience, this is the form. A can be written as A plus 1 minus 1 into D. A plus 1 minus 1 into D. Observe here, A2 is nothing but second term. Second term can be written as A plus 1 into D. 1 is the multiplicative identity. So A plus 1 into D. 1 can be written as our convenience by using its position, that is equals to A plus 1 can be written as 2 minus 1 by using its position, second term. So 2 minus 1 how much? 1 only into D. Next A3 A plus 2D. A plus 2D is equals to 2 can be written as our convenience by using its position. 3 minus 1 into D. A4 is nothing but A plus 3D. That is equals A plus 3D can be written as A plus 4 minus 1 into D. Observe here. A5 is nothing but A plus 4D. A plus 4 can be written as A plus A1 means A plus 1 minus 1 into D. A1 means A plus 1 minus 1 into D. A2 means A plus 2 minus 1 into D. A2 means A plus 2 minus 1 into D. A3 means A plus 3 minus 1 into D. A3 means what? A plus 3 minus 1 into D. A4 means A plus 4 minus 1 into D. A plus 4 minus 1 into D. A5 is nothing but A plus 5 minus 1 into D. So generalize this pattern. If 5 means 5 minus 1, 4 means 4 minus 1, 3 means 3 minus 1, 2 means 2 minus 1, 1 means 1 minus 1. This generalize this pattern. A n is equals to n means what? A plus n minus 1 into D. A plus n minus 1 into D. This is called the general term or nth term. General term or nth term of an arithmetic progression. Okay, this is the general term or nth term of the given arithmetic progression. Observe here, A is the first term and D is the common difference. Then general form of AB is A plus D, A plus 2D, A plus 3D, and so on is a general form of a arithmetic progression. We want general term or nth term. How to find is A1 is equals to this is first term. A1 can be written as A plus 1 minus 1 into D. A2 can be written as A plus 2 minus 1 into D. A3 can be written as A plus 3 minus 1 into D. A4 can be written as A plus 4 minus 1 into D. A5 can be written as A plus 5 minus 1 into D. Observe this pattern, we conclude that AN is equals to A plus n minus 1 into D. This is called the general term or nth term of an arithmetic progression. Let us discuss one example here. For example 14, 9. This is 4 and minus 1 and so on. Observe this sequence. It is in arithmetic progression or not? 9 minus 14. The difference between any two consecutive terms. 9 minus 14 how much? 9 minus 14 is nothing but 9 minus 14 is a minus 5. How much? Minus 5. 4 minus 9 how much? 4 minus 9 is also a how much? Minus 5. Minus 1. Next. Minus 1. Minus 4 is nothing but how much? Is also a minus 5. Here the constant, the common difference is always same. So clearly it is in arithmetic progression. What is the 23rd term? A23 in this sequence, in this arithmetic progression. What is the 23rd term? 23rd term. If you write like this, that means minus 5. Minus 1. Again we subtract minus 5, and this is the time consuming process. If you substitute formula, we have one formula to find the nth term or general term of an arithmetic progression, that is A plus n minus 1 into D. Observe here, this sequence, it is clearly it is an arithmetic progression. Why? Because the difference between any two consecutive terms is always same. So clearly it is in arithmetic progression. It is in arithmetic progression. How to find A23? That means what is the 23rd term in the given sequence? Means here first term A is equals solution. Here first term A is equals how much? First term is equals to 14. First term A is equals how much? 14. We want common difference. Common difference D is denoted by T2 minus T1. The difference between any two consecutive terms is called a common difference. So D is equals to T2 minus 1 or T3 minus T2 or T4 minus T3 or Tn minus Tn minus 1. So D is equals to T2 here. This is T1, this is T2. T2 value how much? 9 minus, this is T1. 9 minus 14. 9 minus 14. Or A2 minus A1. T2 minus T1 or A2 minus A1. Both are equal. Terms are denoted by generally A1, A2, A3, An and so on An. or T1, T2, T3 and so on Tn. So common difference is equal to A2 minus A1, that is 9 minus 14 is nothing but 9 minus 14 is equal to minus 5. 9 minus 14 is equal to how much? Minus 5. So common difference is equal to minus 5. We want a 20th term. We want what? A 23rd term. A 23rd term. 23rd term. We know that. AN, that means a nth term. A nth term or a general term. A n is equal to a plus n minus 1 into d. This is the general term or nth term of the given sequence. So a 20th term, maybe the general term or nth term of the given sequence. How to find the A23 is n is equal to how much? N is equal to 23. That means a nth term is a plus n minus 1 into d. We want a 20th term, 23rd term. So A23 is equal to A value how much? 14 plus 23. M value how much? 23 minus 1 is nothing but 22. And a common difference how much? Into minus 5. Into minus 5. That is equal to 14 plus 23 minus 1. We will get 22 into minus 5. 22 into minus 5. The 22 into minus 5 how much is? A23 is equal to 14 plus 14. 22 5 2s are 10. 1 into 5 2s are again 10. 22 5 is 110. 22 into 5. 5 2s are 10. Again 5 2s are 10. 10 plus 1 how much? 110. Whereas minus 5. So minus 110. Minus 110. We want A23 is equal to 110 minus 14. 110 minus 14 how much means 10 minus 4 is nothing but 6. Next, it has 10 minus 1 is nothing but 96. So 14 minus 110 is equal to minus 96 is the answer. So given sequence 14, 9, 4, minus 1 and so on. What is the 23rd term? What is the 23rd term is A23 is equals to minus 96. So what is the nth term? What is the nth term of the given sequence? Or what is the nth term of the given sequence is? We know that A n is equals to A plus n minus 1 into d. Substitute the values. We want A n is equals to A value how much? 14 plus n value n only n minus 1 into d value minus 5. We want 23rd term is this is minus 96. How to find the nth term is we don't know n value, so leave it there. A value is equals to A plus n minus 1 into we have a d value minus 5, that is equals to 14 minus 5 into plus n is nothing but minus 5n. Minus 5 into minus 1 is nothing but plus 5. Okay, 14 plus 5 how much? 19 minus 5n. 19 minus 5n is the nth term. Is the nth term of the given sequence. 23rd term is minus 96. What is the nth term? Means 19 minus 5n is the nth term of the given sequence. But A is the first term and D is the common difference. Then nth term of A is the first term and D is the common difference of given AP. Nth term is A plus n minus 1 into D. Note L is the first point. If L is the last term of an AB, L is the last term of an AB. That means L means the last term of AB, and D be the common difference. D be the common difference of given AB. Then L is the last term of an AP and dB the common difference of given AP. And how to find the mth term? How to find the mth term from an end of an AP is, that means we have to find from end. We know that from beginning, we know that a plus n minus 1 into d. A means first term, a plus n minus 1, a plus 1 minus 1 into d. How to find the mth term from the end means mth term from the end. Common difference, then mth term from the end. Mth term from the end is, it is denoted by T mth term or T m dash. M dash T m dash is nothing but mth term from the end. Mth term from the end is T m dash or a m dash. Anything, right? A m dash, okay, is L minus m minus 1 into d. L minus m minus 1 into d. If L is the last term, and D is the common difference, then the mth term from the end of an AP is, formula to calculate the formula is Tm dash. Tm dash is nothing but mth term from the end position is Tm dash. Is nothing but L minus m minus 1 into d. L minus m minus 1 into d. Second one. This is on another formula. Tm dash is equals to L minus m minus 1 into d. So how to find the mth term from the end of an AP? Mth term from the end of an AP. Mth term from end of an AP. Mth term from the end of an AP is nothing but is equals to n minus m plus one term from the beginning. From the beginning. Okay? Point. Mth term from end of an AP. Mth term from end of an AP is nothing but n minus m plus 1th term from the beginning. How means? Observe here one example. Let us discuss one example here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We want 1, 2, 3. Third term from the beginning. From the end. We want third term from the end. Third term from the end. Third term from end of an end. Third term from end of an end is how much? 16. Third term from an end of an AP is same as here number of terms. How many number of terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. M value how much? 10. So 10 minus m value how much? 3. 3 plus 1. 10 minus 3 plus 1 is nothing but 10 minus 3 is nothing but 7. 7 plus 1, 8 term. 8th term from beginning. Observe here 1, 2, 3, 4, 5, 6, 7, 8. 8th term is also 16. Third term from end is 16 and 8th term from the beginning is also 16. So that's why mth term from end of an AP, mth term from end of an AP is same as mth term from end of an AP is same as n minus m plus 1th term. N minus m plus 1th term from the beginning. N minus m plus 1th term the beginning. Observe here. Note L is the last term. It contains some number of n number of terms. What is the common difference? What is the mth term? term from the end of an AP is nothing but Tm dash is equals to L minus M minus 1 into D. Last term minus here M value. Mth term from the end is M minus 1 into D is the formula. Tm dash is denoted means mth term from end of an AP. Mth term from end of an AP is nothing but n minus m plus 1th term from the beginning. N minus m plus 1th term from the beginning. What is the properties of arithmetic progression?